You are welcome to the first video of the new course F5 Big IP Advanced WAF, formerly named ASM. And for the first lesson, we are going to answer the question, what is F5 Advanced WAF or ASM module as a security solution? To answer this question, we will discuss the features of the device and how it protects web applications against threats. But before that, first we will introduce OWASP top 10 cyber threats and then how F5 Advanced WAF module helps to protect and mitigate against these threats. To begin discussion, first we will examine OWASP top 10 cyber threats to understand the most critical security risk to web applications. Following that, then we will delve into the features of F5 Advanced WAF and discuss how it safeguards web applications against these threats. OWASP, or Open Web Application Security Project, is a non-profit organization which is known for its OWASP Top 10, a list of 10 most critical web application security risks. The latest version of OWASP Top 10 is from 2021. The next update is OWASP Top 10 2024. Is currently in the data collection phase and is scheduled to be released in September 2024. Let's take a quick look at the top 10 security threats classified by OWASP. First is broken access control. Is a security vulnerability that occurs when a web application does not properly enforce restrictions on what authenticated users are allowed to do. This means users might access data or perform actions they shouldn't be able to, such as viewing sensitive files, modifying other users' data, or accessing admin functions. The next is cryptographic failures, means that sensitive data is not protected through encryption or other methods which can lead to data theft or manipulation. The third one is injection, is sending untrusted data as a part of a command or query in order to execute unintended commands or access unauthorized data. The most common example is SQL injection, where an attacker insert malicious SQL commands into fields that expect user input, such as login forms or search boxes. The next one is insecure design. This category is about errors in the design of software. Examples include storing credentials without proper security, exposing sensitive information through error messages, or failing to properly separate different areas of a program, which could potentially give attackers access beyond their privileges. The next one is security misconfiguration. Occurs when security settings are not properly defined, implemented, or managed, such as not patching known vulnerabilities, using the default configuration, enabling unnecessary ports, services, and pages, and misconfiguring permissions. And the next one is vulnerable and outdated components. As we have discussed, refers to the use of outdated or vulnerable software components without updating and patching. The next one is identification and authentication failures. This involves weaknesses in user identity verification processes, which can allow attackers to impersonate legitimate users. And the next one, software and data integrity failure, refers to the code and infrastructure that does not provide protection against unauthorized changes, which can lead to malicious code or data manipulation. Some examples include downloading code without verifying its integrity or not verifying data authenticity, which allows attackers to manipulate data. The next one is security logging and monitoring failures. Refers to a lack of logging and monitoring which allows attacks to go unnoticed, and breaches may not be detected in a timely manner. And the last one, server-side request forgery or SSRF. This occurs when an attacker can send crafted requests from a vulnerable web application to other systems, often leading to unauthorized actions. Now let's look at F5 Advanced WAF security features to see how this solution can help to protect against security threats. In fact, there are many security features that help protect web applications, but I have listed some of them that will be discussed or implemented throughout the course. The first one is attack signatures. Is a set of rules or patterns that identify potential known attacks on web applications. When traffic comes into the application, the system compares it against these signatures to detect malicious activities. Geolocation enforcement, which can be whitelist or blacklist, allows administrators to control access to web applications based on the geographical location or country of the user. IP intelligence or known malicious IP addresses, blocking client requests from IP addresses with known bad reputation. It utilizes a database maintained by WebRoot's IP reputation service, which lists IP addresses identified for malicious activities such as attacker or exploits. Cookie security, it prevents unauthorized changes to cookies. The most common example is to ensure that session cookies set by web application are not modified on the client side. And data guard prevents leakage of confidential information from web applications. This involves scanning responses for some sensitive information such as credit card numbers or social security numbers, and either blocking or masking this information with asterisks. It can be configured to protect custom patterns using regular expressions to check specific file types or content types. The next one is login enforcement. Protect web applications from brute force attacks. It also protects important pages to be accessed only by authenticated users. File type protection. Manage the types of files that can be uploaded to or from your web application. URL protection allows you to configure allowed or disallowed HTTP or HTTPS URLs in the security policy. Parameter protection. In a web application, a parameter is a piece of data that can be passed between different parts of the application or between the client and server. Parameters are often used in the context of URLs, forms, or function calls within the application code. With this feature, it protects web application with enforcing checks on parameters against a set of rules for things like illegal parameter value lengths and illegal meta characters in value. HTTP header and methods protection, ensuring that only legitimate and expected HTTP methods like get, post, and head or allowed HTTP headers are used in requests. Brute force protection is designed to safeguard web applications from brute force attacks. The feature works by tracking the number of failed logins. If the system detects a high rate of failed logins or a certain threshold is reached, it considers it an attack. Cross-site request forgery or CSRF protection. These attacks exploit the trust of a web application that has in a user's browser, tricking the browser into executing unwanted actions in a web application where the user is authenticated. The CSRF protection feature works by inserting custom JavaScript into response pages, which adds a unique token to each URI and form submission. This token must be present and valid for subsequent requests to be accepted by the server. If a request lacks the correct token, it's considered a CSRF attack and is blocked, thereby preventing unauthorized commands from being executed. XML and JSON protection. It ensures that the structure and content of XML and JSON requests comply with the expected format, preventing common attacks such as XML extended entity or XXE and JSON threats. JSON injection is a type of attack where malicious code is injected into JSON data. XML external entity occurs when an attacker exploits XML parser to include hostile external entities during the processing of XML documents. User tracking is the next one. Written here is monitoring and collecting data on user behavior and activities. This information is used to improve user experience. Session tracking. It tracks user session using login pages, session IDs, or unique device ID for each client. This feature helps identify users or sessions that may be involved in an attack such as session hijacking. Web scraping protection, which extract data from websites, protect web applications from unauthorized data extraction using various methods such as bot detection, excessive session creation from a single IP address, or high data volume transfer. DOS protection is designed to protect web applications from denial of service and distributed denial of service attacks. It is based on monitoring transaction rates on the client side or latency on the server side, ensuring resource-intensive URLs are protected using machine learning to learn application behavior and continuously monitoring server health. Positive and negative security model. Negative security model allows all transactions except those identified as threats or attacks to be transferred. It utilizes attack signatures to detect and prevent common vulnerabilities like web injection and cross-site scripting. On the other side, positive security models block all traffic by default, only allowing transactions that are known to be valid and safe. When used together, they can provide a robust defense for web applications against a wide range of security risks, and normally the both of them are used simultaneously. Audit logging and reporting logs every significant event or change within Advanced WAF module, which is essential for monitoring security events and can be critical for diagnosing problems. And finally, web app vulnerability scanner integration. Advanced WAF module can integrate with various vulnerability assessment tools like HP Web Inspect, IBM App Scan, and Qualys. It uses the result from these scanners to suggest updates to the security policy. In cases where policy builder decision might conflict with scanner result, administrators have the flexibility to determine the final security policy settings. As a network engineer, you are probably interested to know the capabilities that a WAF device brings to our infrastructure compared to an application firewall or IPS. Both systems have overlapping features like attack signatures or attack detection based on attack signatures, data leakage protection, IP intelligence, dust protection, and file protection, and many other features. However, learning capability of F5 Advanced WAF provide an additional layer of security by enabling it to respond to new and evolving threats with more agility. This feature allows Advanced WAF to understand what constructs normal traffic for a specific web application, which can include allowed URLs, file types, parameters, cookies, HTTP headers, HTTP methods, and many other web application components. The automatic learning of F5 Advanced WAF module considers several factors to determine the normal behavior of web application traffic. Among them includes how often a particular type of request occurs, whether the request originates from inside or outside the network, likelihood of each request being an attack, and the HTTP codes generated by the application in response to the request, which indicates the health and status of the application request. On the other side, application firewall IPS monitor all network traffic, but a WAF analyze only HTTP and HTTPS traffic.